Okay, so just in case you found that solution at all confusing or hard to follow, I'll just cover it real quick here. I think the rectangular faces are pretty easy. You had two that are 5 by 12, and one that's kind of on the bottom in the picture here that's 6 by 12. So those were 60, 60, and 72 for their areas. To find the area of the triangular sides, you needed to find the area of that triangle. You knew the sides were 5 and 5, and that the other side was 6, so it's an isosceles triangle. So if we draw in the altitude, it is going to bisect that bottom side. When that gets bisected, it obviously has a length of 3, and it will also be perpendicular to the base. So you have a right triangle there. And remember that there's a Pythagorean triple, 3, 4, 5. So once I know 3 and 5, I didn't even have to calculate to find out that the height was 4. Then I used that height of 4 to find the area of the triangle, which was 6. There were 2 of them, so I had 2 of them in my addition that I did at the end here to find out that the total surface area was 204. I did that in my head, so hopefully I didn't make a mistake. All right, going forward. All right, so now we're going to look at cylinders. Cylinders are a lot like prisms. They have 2 congruent parallel bases, but in this case they are circles. An altitude of a cylinder is the perpendicular segment that joins the bases, so it is how tall it is, or how long it is if that cylinder happens to be on a side. And you can have right cylinders, which the sides are perpendicular to the bases, or you can have oblique cylinders where the segment joining the centers is not perpendicular to the planes. They're tilted off to the side here. So when you find the height, it's going to be this distance between the bases perpendicular to the plane of the bases, planes of the bases. In this book, you may assume that a cylinder is a right cylinder unless stated or pictured otherwise. Oh, I guess they didn't mention. All right, we'll cover it at the end about oblique stuff. To find the area of the curved surface of a cylinder, visualize unrolling it. So really what you have here, if you turn this into a shape net, you start with a cylinder. If you unroll that middle section, it's just a big rectangle. And you can see that the purple length here is the circumference. See the purple circumference? Unrolling the purple circumference. The purple circumference is one of the sides of the triangle. The circumference of a base is 2 pi r, which gives you the lateral area, which is 2 pi r times the height. That's just the middle rectangle. The whole area is the 2 circles plus the rectangle. So the rectangle is 2 pi r times h. So the surface area, if we unpack this a little bit, is 2 pi rh plus 2 pi r squared. So the lateral area plus the 2 circles on the top and bottom. Each circle is pi r squared, and that's why we have 2 times pi r squared, because we have 2 of those circles. And pi r squared, of course, is just the formula for the area of a circle. Oops. All right. Finding the surface area of a cylinder. So the radius of the base of a cylinder is 4 inches and its height is 6 inches. What is the surface area of the cylinder in terms of pi? So that's nice because we can probably do these calculations in our head. But you also probably want to sketch a quick picture. So we've got a cylinder. So we'll draw 2 circles and 2 lines. Cylinder, it's not perfect, but it's good enough. The radius of the base is 4 inches. Its height is 6 inches. We know that we have to do our formula from before, which is surface area equals the height. Well, let's grab it real quick. Hopefully you have it down in your notes. I don't. It's this. So we're going to use this formula. Stop that. Give me this. There we go. Boom. I wonder if it'll let me. Let's erase that. All right. So the surface area, 2 pi r times h. And once I know this formula, I need to think about it a little bit because there are always quirks, or they want to test you to see if you really know it. But I do. So I'm going to plug in the radius, which is 4, the height, which is 6, plus 2 pi times the radius squared, which is 4 squared. Now, this multiplication here, 2 times pi times 4 times 6 is, well, 2 times 4 times 6 is 24, times 2 is 48. So this first part is 48 pi. The second part is 4 squared, which is 16, times 2, which is 32 pi. 48 pi plus 32 pi is a total of, let's see, 80 pi. So 80 pi inches squared is the correct answer. That's how you find the area of a cylinder. For you to try out here, we have a cylinder has a height of 9 centimeters, a radius of 10 centimeters. What is the surface area of the cylinder in terms of pi? Go ahead and give that a shot.